It's called as MRI. So obviously one of our colleagues yesterday got an MRI for us, me. Okay. So I'm going to just tell you what are the basic principles of this MRI. What is MRI basically? If you happen to see the expansion of MRI, it is magnetic
resonant imaging.
Resonance imaging. Magnetic resonance imaging. Okay. I'm going to just justify what is the need for the word magnetic, the need for the word resonance, and the need for the word imaging. So basically, what imaging means is you want to see what is happening inside the body. You want to take an image. That is one way of doing it. One way is take a camera, go inside the body, take an image. So that is actually done. You call it as an endoscope. Endoscope actually is a long tube which has a camera and it goes directly to the point and it takes an image. Whereas the other way of doing the thing is you use some phenomenon connected with that. Suppose, as a friend said, it's about the X-ray. When X-ray is passed to the body, certain areas it's getting absorbed, certain areas it's getting attenuated. Based on that, you will be able to tell what is the, you will be getting an image. You will be getting what is happening inside. In a similar manner, we want to get something that is underlying in our body by using some physical mechanism instead of directly taking a camera inside the body. Okay, so that is basically an imaging. What is so special about this MRI is it does not use any harmful radiation. If you take your X-ray or a CT or a PET scanning, wherein you use a lot of radionuclides, you use a lot of X-rays. Okay, so in MRI you don't have any harmful radiation reported so far. Okay, that's a very good advantage of MRI. So that's about imaging. What is to do with magnetic? So if you happen to go inside an MRI room, what you will experience is it will be super cool. It will be very, very cool inside the magnet because it has a very big magnet inside. You know what will be the strength of the magnetic field? It is nearly 10 times the Earth's magnetic field. It's nearly 10 times the Earth's magnetic field. That will be the intensity of the magnetic field. So inside this magnetic field, the human body is placed. What happens is a question. Okay, what happens basically is what here concerned is we all know that human body is composed of 70% is water. Larger content of our body is water. Of that water, what is fundamentally water is H2O. And the fundamental thing is you have more amount of hydrogen that is present in the body. What happens to this hydrogen is, if you see a hydrogen is a positively charged proton. It contains one proton. It's a positively charged proton. What is the nature of this proton? If you happen to see a proton, it will be like this. The nature of this proton is it spins on its own axis. Like the Earth. Like the Earth, it has a spinning action. It rotates on its own axis. Okay. So the proton actually spins on its own axis. Whenever you have and it also carries a charge. It also carries a charge due to the spinning or moving electrical field. It creates a magnetic field. It creates a magnetic field. Okay. So what I essentially want to say is each proton in your body is going to act like a bar magnet. Each proton in your body is going to act like a bar magnet. And what is the nature of this bar magnet is you have good number of hydrogen atoms in the body. All these are present random inside the body. They are present in random dash. You take the human body, each one is in one dash. Okay. When I put this under a magnetic field, what happens is that all, say this is a magnetic field, all these protons align parallel to the magnetic field. All these protons align parallel to the magnetic field. I just put in a simple analogy. Suppose it's the scenario before a teacher enters a class. What happens before a teacher enters a class? So all the students will be randomly sitting. They will be occupying different places in the class. As soon as the teacher enters the class, most of the students will try to orient towards the class. Again I repeat, most of the students, not all students. Some students will engage with their own activities. They will be using their mobiles or they will do their observation record work. Okay. For them, they should have some extra guts. Okay. They are opposing the actual activity. So they should have some extra guts. In a similar manner, whenever you put the protons under the magnetic field, most of the protons will align parallel to the field, whichever are having low energy. And few protons which have high energy align anti-parallel to the field. Most protons align parallel, few align anti-parallel. Okay. The result of this, you create a, so you have more number of protons, and this rotation of this proton, you call it as precession. The rotation is called as precession. And this precession frequency again depends upon the strength of the magnetic field. It's like this. The magnet is the faculty who is coming inside. Students are the protons. Suppose a very new recruited faculty comes inside the class. Not all will orient immediately. Okay, we know that guy is an M.Tech, he studied here. Why should you immediately respond to him? So he will be quiet. Suppose a very well-trained faculty comes. The orientation increases. HOD comes. Still further the orientation. Suppose the principal comes. The orientation further increases. So the orientation depends upon the strength of the magnetic field. Okay. So similarly here, when the magnetic field strength is very high, all these protons will align. And as I told, there are few protons anti-parallel. Because of this anti-parallel effect, it gets cancels. Only few protons will be anti-parallel. The effect gets cancelled, and most of the proton will be parallel, which will give rise to a new magnetic field. Which I call it as longitudinal magnetization field. Longitudinal magnetization field. So I am able to justify what is the need for a magnet. Now comes the second. Yeah. So we have created a new magnetic field, but the problem is this magnetic field that you have created is in the same direction as that of the original field. It cannot be measured. For example, let me put in simple analogy. A person is traveling in a boat. It's a small pond, and what he's doing is that he's actually taking a pipe and he's putting some water inside the pond. It's already, don't be logical. He's in a boat, he's in a small pond, he's flowing some water into the pond. He's flowing some water, but that is again going into the pond. You cannot measure what is the amount of water. To measure the amount of water, if you reverse the direction, you change the direction. If you change the direction, you'll be able to measure. Suppose one person is in the shore, he has a bucket. You can just pour the water to him and he will catch the water. And you'll be able to tell what is the amount of water. So, the idea is, you have to change its direction from this point to this point. If you want to change something, change the direction, you need to do something. Okay. Suppose there are two cars. Okay. We have two cars going in a race. One person is very hungry, another person is having a burger. Okay. When the person in the car can give the burger to the other person, when both are at same speed. When both are at same speed, the burger can be shared. Okay. So, if you want to move this proton, that is, it has to be given some extra energy. So, you send another signal, it's called as a RF signal, at the same frequency as that of the original signal. Okay, like the sharing. So, when you give the energy, extra energy, the protons get the extra energy and they move out of phase. Okay, and it will establish a new magnetic field, is called as transversal magnetic field. So this principle is actually called resonance. When the frequency match, there will be sharing of energy. Okay, this is the basic principles of MRI. Thank you.
Good. Quickly.
Feedback to yourself.
Feedback.
I took a time more than that. I stuck in between very minutely. Okay, bit nervous.
No, start with the good things.
Yeah. Good thing I was audible. I gazed around everyone. I had a visual eye contact with everyone, and I'll be more audible. And normally I'll obtain the feedback from your eyes. How far you're able to get things. That's the advantage. And disadvantage, the things I want to improve is my English. Sometimes I use repeated words. I use some repeated words again, okay. Some words I'll be using again and again. So those things I need to improve. That's it.
So do you use that because you are out of the vocabulary? I mean, what you want to speak, you don't have that word. Is it because of that, or is it because of the habit? That normally sometimes what happens, this is a habit that we tend to do that. That is a filler. That is a different challenge. Versus if I do not have the vocabulary, I do not have the words. So which one? Which one is it? A habit? Habitual. Okay. Which is with the practice definitely that that will go away. Yeah. Okay. Thank you very much. Thank you.